Hello everyone, welcome to second numerical of uh, relationship. And before this video we have already done one numerical related to this chapter. Okay, we are studying soil moisture and crop relationship, and we have already done this numerical asked in Pokhara University 2024, and in this video we are going to solve the numerical of world question that is asked in Pokhara University 2019 fall. Okay, so let's see the solution of this numerical, and I strongly recommend please visit the first numerical, and I have explained the different concept related to this chapter. Okay, so after visiting the first video you can understand this second numerical very easily. So you have to first see the first numerical, and I will keep the link of that video in description box. Okay, so you can simply visit from there, and I have uploaded different numerical of irrigation engineering and theory, so you can simply visit to the channel and get that video. Okay, so let's see the numerical. So we have given numerical here. The cultivable command area of a water course in 1200 hectare. Okay, so we have given cultivable command area. Simply we can write here CCA equal to 1200 hectare. Intensity of sugarcane and wheat crops 20% and 40% respectively, and the intensity is given. Intensity for sugarcane equal to, we have given here 20%, and for the wheat it's given 14% respectively. The duties for the crops at the head of water course are 730 hectare per cumex, and the duty is given over here is 730 hectare per cumex and 1800 hectare per cumex respectively for the sugarcane and wheat. So we just write here the duties of sugarcane and wheat equal to 730 and 1800 hectare per cumex. Okay, so this is also given in the question, and now we have to find the discharge required at the head of water course, and in second number determine design discharge at the outlet. So we have to calculate these two value. So as we see, this value are given in the question, and this is also the cultivable command area is given 1200 hectare. Okay, so simply we can calculate the area to be irrigated under sugarcane. For the sugarcane we can calculate the area equal to simply the duty is multiply the intensity percent. Okay, so we have we have total area equal to 1200. Okay, but for the intensity for sugarcane equal to only we take 20% of area, so we have to just multiply with this value. So the value equal to 0.2, and after calculating the value of area to be irrigated for the sugarcane equal to 240 hectare, and in same way the area to be irrigated for the wheat we can calculate 1200 by the intensity of wheat, that is 40%, and simply we take the value of 40% as 0.4. Okay, so the area of calculated for the wheat equal to 480 hectare, and one thing you have to know, after adding these two value for the sugarcane and for the wheat, the value must equal to the total value. Okay, total value of culture command, that is 1200. So let's sum this value after calculating adding this value, that is 480 and 260. The value this becomes 480 plus 240. The value becomes simply and this value becomes 720. Okay, we have the overall area is 1200 hectare, but we only take the 60%. That's why the total area after adding the sugarcane and wheat becomes 720 hectare. Okay, as you know, and now we have to duty of sugarcane equal to 730 hectare per cubic. This is already given in question. You can see here the duty of crops at head of water course and respectively. Okay, so for sugar cane equal to 730 hectare per cubic, and for the wheat 1800 hectare per cubic. Okay, now we can simply calculate the value of discharge for required of sugar cane equal to simply we have to divide area by the duty. Okay, so we have already calculated the area, and the area calculated for the sugar cane equal to 240. So we just take area equal to 240 and duty is given by the question, and duty of sugar cane equal to 730. Just we have to divide for get the discharge. Okay, for getting the discharge, so we get the value of discharge for the sugar cane equal to 0.33 cubic, and for the discharge of wheat equal to area by duty as we done previously for sugar cane. So the value of area for wheat equal to 480. Okay, you can see here 480 hectare we have calculated, and duty is given by the question, that is 1800. Okay, you can see here 1800 hectare respectively. So that value is taken here. So the value of which becomes 0.27 in cubic. Simply cubic means meter cube per second. Okay, as you know, the value of 0.33 meter cube per second. Simply it is called cubic, and 0.27 meter cube per second. Okay, this is also in meter cube per second. Okay, so we have already calculated the discharge of sugarcane and for the wheat. Now as we have to determine the discharge required at the head of water course. Okay, for as sugarcane is a perennial crop, as we know sugarcane is a perennial crop, and wheat requires water for only rabi season. Okay, but for the wheat it only require water in rabi season, but sugar can be this is perennial crop. Okay, and that's why the water required for the crop at the head of water course, simply we have to add these two value. So as we calculated the discharge for the sugar cane equal to 0.33 plus discharge for the wheat 0.27. So we just have to add these two value. After adding these two value, we will get 0.63 cubic. Okay, so we have calculated this discharge required at the head of water course. Okay, so simply you can say discharge required at the head of water course. Okay, and it becomes 0.6 cubic. And in second number you can see here we have to determine the design discharge at the outlet. Okay, for this design discharge of outlet we have to take the time factor, that is 0.8, since channel runs fewer days than the crop days. Okay, why we take on 0.5? Because the channel runs fewer days than the crop days. Okay, that's why we take the value 0.8, and discharge design discharge at the outlet equal to simply design discharge at outlet we can calculate by discharge required at head of water course with the we have to divide this value with the time factor. Okay, time factor. Okay, and the time factor is simply 0.8. So the value of discharge required at the head of water course we have already calculated. That is the value of this became, you can see here, 0.6. Okay, so simply we have to divide 0.6 with time factor. Time factor, as we take the time factor equal to 0.8, the value of design discharge at outlet becomes 0.75 meter cube per second. Okay, in this way we can calculate these two value. Okay, as I said in question. So we can simply calculate this value. So let's summarize. first thing we have to know about the calculating the area. Okay, so simply you can calculate the area with the given intensity. Okay, so we have to multiply these two value, and after calculating the area you have to calculate the duty for the duty for different that is in this question sugarcane and wheat. So we calculated duty, and this duty is may given to the question. In this question already the value of duty is given. Okay, and after that we have to calculate discharge required for different for the sugarcane and wheat. So you can simply calculate discharge by the dividing of area by duty. Okay, area by duty gives the value of discharge. After this value, simply we have to add both these two value, then we get total discharge. Okay, so in this way we can calculate different parameter asked in question. Okay, so I hope guys you will understand well. Thank you very much. If you have any queries, please comment down below. Thank you very much. See you in next video. Okay, and for the basic concept I have already done some basic concepts, and also the relation between duty delta and base period as in previous video. So you must see the previous video. Thank you very much. See you in next video. Okay, and next video we will also do different numerical related to this topic. So you have to see this video too. Okay, so stay tuned. Thank you very much. See you in next video.